Let's talk about etcd and console. These are examples of service discovery tools. They help the different parts of a distributed system find and communicate with each other. Think of it like a phone book for microservices. Let's delve into availability through distributed architecture. A system is distributed when spread across multiple machines. If one machine fails, the others keep the system running. This provides redundancy, thus increasing overall availability. Let's explore Vald node n. This represents any number of Vald nodes in a distributed Vald cluster. Each node holds a portion of the vector data and contributes to the overall AND search process. The more nodes, the greater the capacity and fault tolerance usually are. Let's discuss load balancer. A load balancer distributes incoming requests across multiple Vald nodes. This prevents any single node from being overloaded, improving performance and availability. Now, let's consider gRPC and REST APIs. These are standard ways for applications to interact with Valve. gRPC and REST define how requests are made and how data is exchanged. Let's explore client applications. These are the applications that use Valve to perform vector searches. Examples include recommendation engines, image search tools, and fraud detection systems. Now, let's explore Valve gateways. These act as intermediaries between client applications and the Valve nodes. They handle tasks such as request routing, authentication, and load balancing. Let's look at Valve Node 1. This represents a single server or instance within the Valve cluster. Each node stores a subset of the vector embeddings. Now, let's consider Valve Node 2. It is another server within the Valve cluster, working in conjunction with other nodes to store and search vector data. Let's talk about the storage layer. This is where the vector embeddings are physically stored. It could be a local disk, a network file system, or a distributed storage system. Let's reiterate about the storage layer, as there are 3 of them. As stated earlier, this is where the vector embeddings are stored. Since there are 3, this represents data replication or sharding across multiple storage locations for redundancy and scalability. Let's talk about the storage layer again. Remember, this is where the actual data lives. Think of it like the hard drive of each Valve node. Let's discuss vector data. This is the numerical representation of your data, whether it's text, images, or audio. These vectors are what Valve uses to find similar items. To reiterate about the vector data, there are 3 of them. Having multiple instances of vector data likely implies replication or sharding of the vector embeddings across the Valve nodes for improved performance and fault tolerance. Let's talk about the vector data again. Remember, this is the core information Valve is searching through. Each vector data entry represents a chunk of the overall dataset.